Lesson 3.1 is on graphing linear equations, and in this lesson we're going to kind of focus on two different things. We're going to focus on finding intercepts, and we're going to focus on standard form. Those two things kind of go together, and they're going to help us start graphing linear equations. So let's take a look. Some new vocabulary that we are going to talk about is, you've had linear equation before, you know what that is. We're going to talk about standard form, what a constant is, and I think that most of you probably know what a constant is, and we're going to talk about x-intercepts and y-intercepts. So let's take a look and see what standard form is. Okay? Standard form is just a certain way of writing a linear equation. And if you take a look, standard form is written right here. ax plus by equals c. Okay. Where a, your coefficient of x, has to be greater than or equal to 0. Okay. And a and b both cannot be 0. And then a, b, and c are integers with a greatest common factor of 1. Okay. So what we're looking at is we have to have our x and our y on the same side. C has to be on the other side. And a has to be greater than 0, and it has to be an integer. Okay, so we're going to have to do some rearranging and some multiplying to get things written in standard form correctly. Okay, for example, this is an example of an equation written in standard form. 3x plus 2y equals 5, where a is 3, b is 2, and c is equal to 5. Okay? Alright, so let's look at this equation right here. 3/4 x equals y plus 8. And let's write that in standard form. Well, the first issue is we need to have this y. It needs to be on the other side. It needs to be over here with the x. Okay? So, to do that, okay, we are going to subtract y from both sides. And then what we have is 3/4 x minus y equals 8. So now that we have the x and the y on the left hand side, and the c, or the constant, on the right hand side, now we need to focus on what a is. Okay, and you can see that a is not an integer. Okay, it is greater than 0, but it's not an integer. So what we need to do basically is get rid of this fraction. Okay, so to get rid of that fraction, we are going to multiply by the denominator. Okay, we want to get rid of this 4, so we're going to multiply every term by 4. 4 times 3/4, 4 times 4, and then 4 times 8. Okay, we're going to use a little bit of distributive property. So what happens is our new equation becomes 3x minus 4y equals 32. And now we have our a is greater than or equal to 0, and it is also an integer. So now this right here is written in correct standard notation. So I want you to go ahead and check your progress problem, y equals 4x minus 5, and see if you can write that in correct standard notation, or standard form. Go ahead and pause the video. Okay, the first thing we need to do is we need to get that 4x over here with the y. So to do that, we need to subtract 4x from both sides. But the problem is now we have this coefficient of x. It's not greater than 0. It's actually a negative number. We need it to be greater than 0. So what we're going to have to do is we're going to have to multiply the entire equation by -1. So what happens is this becomes positive. Now we're okay. Our a is an integer. Okay, that's greater than 0. So what happens is this becomes a positive 4, this becomes a minus y, and this becomes a positive 5. We use the distributive property on each term inside this equation. Okay, so now here 4x minus y equals 5 is written in correct standard notation, standard form. Okay, the next thing we want to concentrate on is finding x and y intercepts. So the first skill of this is just identifying them. Can we look at a graph and tell what the x and y intercepts are? Well, the x-intercept is the place where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. So if you take a look at this graph right here, your x-intercept is going to be at 4, and your y-intercept is at 200. And that's all we need to do to identify. Just know what our x and y-intercepts are when looking at a graph. So go ahead and try this one. Pause the video, and I do want you to write down what is your x-intercept and what is your y-intercept. Okay, if we take a look at our graph, here's our x-axis. Well, where does it cross the x-axis? Crosses the x-axis at 10. So our x-intercept is 10. Where does our line cross the y-axis? Okay, it crosses at 250. So your y-intercept is 250. Okay. What we want to do now, though, is we want to use those intercepts and we want to interpret what does that mean within the context of our graph. Okay? Let's look at this, your example 3. A box of peanuts is poured into bags at the rate of 4 ounces per second. The table shows the function relating to the weight of the peanuts in the box and the time in seconds the peanuts have been pouring out of the box. Okay, so here's our table, and they've taken our table and put it into a graph. Okay, here's your time in seconds, and then here's the weight of the peanuts. So first thing they want you to do is determine the x and y intercepts of the graph of the function. Well, if we're looking at our graph here, here's our x-axis, so here's our x-intercept, and that's at 500. Okay. Our y-intercept along our y-axis is at 2,000. Even if we didn't have this graph, you could look up here at your chart. Okay, look right here. When x is 500, y is 0. So this is actually like the coordinate or the ordered pair for your x-intercept. 500 and 0, right here. To find your y, you're going to find out where x is 0. So 2,000 and 0, or I said that backwards, 0 and 2,000, there is your y-intercept. Okay? Now, B says, describe what the intercepts in the previous problem mean. So what do these actually mean? We know the numbers, but what does that mean in context of this peanut problem? Okay, so if we look at our graph here, it says the x-intercept 500 means that after 500 seconds, there are 0 ounces of peanuts left in the box. Again, your x-axis represents time. So at 500 seconds, you've got 0 peanuts left in the box. Your y-intercept of 2,000 means that at time 0, or after 0 seconds, there were 2,000 ounces of peanuts in the box, meaning when they started, there were 2,000 peanuts in the box before they started pouring them out. Okay? So we're doing two things here. We're identifying the intercepts, but then we also have to interpret, well, what do they mean in context of the problem? Okay, so why don't you go ahead and pause the video. You're going to do the same thing. You're going to determine the x and y intercepts. Then you're going to describe what they mean in context of this problem right here. Okay, Jules has a gas card for a local gas station. The table shows the function relating the amount of money on the card and the number of times he has stopped to purchase gas. Okay. Determine the x and y intercepts of the graph of the function. Well, we don't have a graph, but we do have this chart. Okay, if this is your x and this is your y, your x-intercept, okay, is when y is 0. So your x-intercept is 5. Your y-intercept is when x is 0, so your y-intercept is 125. Okay, again, your x-intercept is 5 because y is 0, and your y-intercept is under 25 because that's when x is 0. Now, we have to describe what does that mean in terms of this problem. Okay, well, what it means is at the time of 0, or before any food stops, there's $125 on the card. Okay, that's what the y-intercept means. If you look at your chart here, your y-intercept is $125. After 0 number of stops, there's $125 on the card. That means that's how much he started with. Okay? The last thing that we're going to do is we're going to use these intercepts to graph. And that's the nice thing about standard form. If it's written in standard form, it's very easy to find the intercepts. And once you have the intercepts, it's very easy to graph. Okay, so we want to graph 4x minus y equals 4. And we're going to do that using intercepts. So what we have to do is let's find the x-intercept first. So to find the x-intercept, we have to make y 0. Okay, so we're going to take this y, plug in a 0. We simplify, and we get 4x equals 4. We divide, and we get x equals 1. So your x-intercept, or where it's going to cross the x-axis, is at 1. Now, let's find your y-intercept. So to find your y-intercept, we're going to do the exact opposite. We're going to make x 0, so that y stays in the equation. So if we simplify, we get negative y equals 4. Divide both sides by negative 1, and we get y equals 4. Negative 4, sorry. So with those two intercepts, okay, of x being 1 and y equaling negative 4, we're going to plot those. Here's where x is 1. Here's where y is negative 4. You've got your 2 points on your graph. Now go ahead and draw on your line. Okay? Again, and even once you get used to doing this, you can probably find the intercepts in your head. So a lot of times when it is written in standard form, it's kind of easy to graph because you can find the intercepts rather quickly. All right, is this the correct graph for 2x plus 5y equals 10? Okay, well, I think it's already written on your outline that it is, yes. Okay, I forgot to take that answer away. However, we have to prove it. So if we want to find our x-intercept, we are going to make y 0. Simplify, get 2x equals 10. So x equals 5. Okay, so let's see, is that where it crosses the x-axis? 1, 2, 3, 4, 5. All right, our x-intercept is correct. To find our y, we're going to make x 0. We're going to simplify, and we get y equals 2. Is that where it crosses the y-axis? Yes, it does. So that is why this equation right here is the correct graph. All right, so we will come in tomorrow and we will talk a little bit more about standard form and the intercepts.